All right, it is notes time. Today we're going to be talking about unit conversion and dimensional analysis. Again, I have Cornell-style notes, so you have your questions on the left, questions, main ideas, topics, vocabulary, and your main information over here in the right main section. So first vocabulary term is conversion factor. A conversion factor is a ratio that has a value of 1. So that means that it is a ratio or a comparison in which both pieces are equal, even if the numbers are different. I'm going to go ahead and keep talking. It'll make a little more sense as it starts to sink in. So what is an example of a ratio? So a ratio example could be if you have 3 oranges and 2 apples, what is the ratio of oranges to apples? So this is something you've probably done in math before. Basically, it's the comparison of oranges and apples. So what is the ratio of oranges to apples? Well, I can write it as 3 oranges to 2 apples. Or, how else could I write this? There's 2 more ways I can write this. I can write it with that colon. I can do 3 colon 2, 3 oranges to 2 apples, or I can write it as a fraction, 3 oranges for 2 apples. So in math class, we would probably just write it as numbers. This is science, so I'm going to put my units. My units is oranges and apples. They're units because they're how I'm measuring what I have. I'm measuring how many fruits I have. I have 2 apples and 3 oranges. I can also write my ratio in the opposite direction. So what is the ratio of apples to oranges? Take a second on that. Oranges to apples was 3 oranges to 2 apples. So what should apples to oranges be? It should be 2 apples to 3 oranges. I'm going to keep that little thing hidden right there. We're going to make a little surprise. So I have 2 apples to 3 oranges, or I have 2 to 3, or I have 2 apples, 3 oranges. And I'm running out of room. So that's how you do ratios. Probably nothing groundbreaking, nothing new and exciting. So let's move on. If a starfish has 5 points and looks like this lovely guy right here, so starfish, you know what that is. They could have a whole bunch of little pointy thingies, or they can look just like Patrick here, and they can have 1, 2, 3, 4, 5. So if a starfish has 5 points, how many points do 3 starfish have? Now you guys are in 8th grade. I bet you could do this one in your brain. You're not even writing anything down at all. You can probably already tell me, well, 3 starfish, each one has 5 points. 3 times 5 is 15. You would be exactly correct. So 3 times 5 equals 15. But just because I want to make it a little more interesting, we're going to change up how we do it. So we are going to say that 1 starfish equals 5 points. And this is actually going to be a conversion factor, or a ratio, 1 to 5. So if I know that I have 3 starfish, I'm going to start with 3 starfish, and then I'm going to multiply it by, I have 5 points per 1 starfish. Okay, so I'm still doing that 3 times 5 that you already knew we should be doing. But I switched it up by putting some units on top of it. So starfish and points. Starfish are diagonal from each other with a multiplication in between. This means I can cross them out. Cross-canceling. You probably have already learned how to do this with numbers. So if you had factors, like 3 times 2 times 4, or 3 times 2 times 2, and down here you had 2, you could cross out the 2's. But in this case, instead of having a number, I have a unit that's the same, so I can cancel out those units. So what I'm left with is 3 times 5 points equals 15 points, and then 1 times 1, nothing. So it's just 15 points. So how many points do 3 starfish have? 15 points. Okay, so another way I could do a question like this. How many starfish are there if you count 40 points total? Okay, so I already know that there's 40 points, so, like I have all these starfish, and I get 1, 2, 3, 4, 5. Then I would have to draw another one, 6, 7, 8, 9, 10, and I could keep doing that until I reach 40. Or you probably are thinking, come on, Miss Riggle, do not sit there and draw a bunch of stars. Just divide. Okay, I can divide. So you probably know 40 points divided by 5 points per fish equals 8 fish, or starfish. How do I do that? Using conversion factors, though, because we are just converting units. We're converting between starfish and points. So I'm going to set it up as 40 points times, and then I'm going to put a conversion factor in here. Let's see, I know I have 5 points for every 1 starfish. With me so far? And I'm going to put that over 1, so I'm multiplying fraction times a fraction. Points and points, those are diagonal, so I can cross-reduce those. So 40 times 1 starfish equals 40 starfish over or per 1 times 5. So now I just have my division. 40 divided by 5 equals 8 starfish. Not too bad. So we're going to actually be doing some problems that are going to use this style of setup right here. They just might not be as intuitive as these two right here. So these ones right here, I use some common things that you might be able to imagine in your brain and made it so that we could work with it. But we're going to have to set our conversion factors up just like this. And if you always do it this way, where you make sure you can cancel out your units, you'll always get the right answer. Okay, so new vocabulary term, dimensional analysis. Dimensional analysis is a method of using conversion factors and unit canceling to solve a unit conversion problem. This right here and this right here, actually move down. So these two ways that I solved the starfish problem, that was using dimensional analysis. Solving it this way, where we just said, oh yeah, it's totally just like 3 times 5. That's like, that's some elementary school stuff. We're in middle school. We're doing dimensional analysis. Thank you very much. Okay, so dimensional analysis has specific steps. So, what are the 4 steps of unit dimensional analysis? The first step is we identify the unit that needs to be converted. So, I'm going to come back to this. How many points do 3 starfish have? So, 3 starfish, that was my start. Starfish is the unit that needed to be converted in this first problem. Step 2, list the conversion factors. Actually, I'm going to say right here. So, for example, 3 starfish. Our conversion factor, 1 starfish equals 5 points. And again, I'm not talking about like game score points. I'm talking about the points of the star on the starfish. So So I'll draw a little star. I won't draw Patrick again because that took me too long. Step 3, write the conversion factors as fractions. So I'm going to take 1 starfish and 5 points, and I can write it as 1 per 5. Or I can write it as 5 points per 1 starfish. So right now when I'm just writing the fractions out, it doesn't matter which one is the numerator and which one is the denominator, just as long as I know that either of these are the same. Because this is a ratio that equals to 1, it can be the same whether it's itself or its reciprocal. Step 4, cancel units and solve. So that was where we multiplied our 3 starfish times 5 points per starfish, canceled out the starfish, came up with our number. So over here I have identify, list, fractions, and cancel. Those are our 4 steps. All right, let's do our first real example. So dimensional analysis, example 1. Use dimensional analysis to convert the time unit in a speed. So our first example, the speed limit on the 10 freeway at some points between Phoenix and Tucson is about 70 miles per hour. What is this speed limit in miles per second? Okay, so we're going from hours into seconds. We need to figure out how to do that. So step 1 is identify the unit that needs to be converted. So the unit that we're starting with is the one that needs to change. Miles per, those are staying the same, but hour is turning into second. So identify hours, and I'm just going to use this little arrow because we're talking about notes, and that for me is going to mean into or yields or becomes seconds. So that's my identity. Now we need to list any conversion factors that are going to be useful. So if you know off the top of your head how many seconds are in 1 hour, you could write that down. But if you're like me, you don't necessarily remember that one. I want to say it's 3,600, but let's keep going. So I know that 1 hour equals 60 minutes. Okay, it's 360. I would have been wrong. And I also know that 1 minute equals 60 seconds. So I could also use the conversion factor of 1 hour equals 300. No, it is 3,600. Let me actually multiply that out. Yeah, 3,600. Okay, so 1 hour is 3,600 seconds, or I can use 1 hour equals 60 minutes and 1 minute equals 60 seconds. Either of these ways will get me to the same answer. It's just this one will have an extra step in it. Write my fractions. I'm going to use this one right here. My 1 hour equals 3,600 seconds, because that conversion factor is going to get me done faster. So I could have 1 hour over 3,600 seconds, or 3,600 seconds over 1 hour. Okay, so would you agree that 1 hour and 3,600 seconds are the same thing? So if you divide something by itself or something by the same thing, you're going to get 1. So this is a fraction or a ratio that equals 1. This is also a fraction or a ratio that equals 1. So these are my conversion factors I can use. And I can use either one of these, whichever one is going to cancel out correctly. So step 4, I need to cancel and solve. Well, so let's start it out. We had 70 miles per hour. So I'm going to write that as 70 miles. And remember, you can read a fraction bar as per 1 hour. So 70 miles per 1 hour, 70 miles per hour. And then I'm going to multiply it by my conversion factor. Which of these should I choose? which of these is going to cancel out the hour and leave me with seconds? Okay, so is it this one or that one? I need to be able to cancel out my hours. So sometimes what I'll do is I know I'm going to use a fraction because I'm about to use one of these conversion factors. And I know I'm going to have to cross-reduce. So I have hours on the bottom. That means up here, I need hours on the top so they can cancel. So which of these is that going to be? It's going to be this one. So 1 hour over 3,600 seconds. Now I can cancel out hours. So I haven't even finished the problem yet, but I already know my units are going to be left with miles per second. So I know I'm on the right track. So I know as long as I do the math correctly, I've already solved it. I'm already good to go. So I have 70 miles per 3,600 seconds. Sorry for the weird edit, but I made a mistake the first time around on this division here, so I'm just going to go back again and try it over. I did 360 divided by 7, but it's supposed to be 7 divided by 360, just the way it's set up right here. So I'm going to do 7 divided by 360. And I'm just going to add 2 more zeros, and we'll call it. 360 goes into 7 one time. 1 times 360 is 360. 0 minus 0 is 0. This 0 becomes a 10. 7 becomes a 6. 10 minus 6 is 4. 6 minus 3 is 3. Okay, 340. I'm going to bring down my 0. Oh, I should keep my decimal place right there, and my zeros. Sorry, guys. Okay. 360 into 3,400, I'm going to go with 9. 9 times 0 is 0. 9 times 6 is 54. Write my 4, carry the 5. 9 times 3 is 27, plus 5 is 28, 29, 30, 31, 32. So I'm going to write 32. Subtract 0 minus 0, 10 minus 4, 3 minus 2, and 0. So I have 160. So I'm going to just do this one last division. 360 into 1,600. I'm going to say that's 4. 0 times 4 is 0. 6 times 4 is 24. Carry the 2. 4 times 3 is 12. Plus 2 is 14. 0 minus 0. 10 minus 4 is 6, 5 minus 4 is 1, and I'm left with 160. But I'm going to just stop it and round it off at 3 decimal places, so my number is 0.0194 miles per second. So now for the next example, it wants me to use dimensional analysis to convert distance units in a speed or a rate. And I'm going from 70 miles per hour to meters per second. So I could start at the very beginning with 70 miles per hour and then convert my hours to seconds and then my miles to meters. Or, since I already know miles per second, I can actually start there. So I already know I have 0.0194 miles per 1 second. And I'm trying to go from miles to meters. So what are my conversion factors I can use for that one? I have paper that wants to fall. Let's put that over there. So let me look up my conversion factor. Alright, so I have my 0.0194 miles per second times, I need to find my conversion factor, which I'm going to be using 1,609.4. 609.4 meters per 1 mile. So I need to set that up in a fraction to where I can cancel out my miles. So I'm going to have 1 mile on the bottom and 1609.4 meters on the top. Miles and miles are going to cancel because they're diagonal and across a multiplication sign. And then I will work it out. This is a lot of numbers and a lot of numbers, and we're not a math class. So I'm going to grab this right here, turn it on. I'm going to multiply. Move that right there so we can see everything. I'm going to multiply 0.0194 times 1609.4, and it gives me 31.22236, but I need to round this off to my original things where I said 3 places. So I'm going to round to 3 sig figs I'm going to do. So that's going to be to right there. 1, 2, 3 sig figs. So my answer is 31.2 meters per second. So example number 3, convert 1 year into seconds. How should we do that one? All right, so let's start out with our conversion factors that we know. We already know that 1 hour equals 3,600 seconds. What else do we know? How many hours are in 1 day? 24 hours equals 1 day. And how many days are in a year? Most calendars would say 365 days. But I'm going to say it's actually 365.242 days equals 1 year. That's why we have leap years, because it takes just a little over 365 days to make a full circle around the sun. So every 4 years, we add in an extra day. So 0.242 is just under 1/4. So every 4 years, we even it out, and we're good to go. So I know 1 hour to seconds, I know hours to days, and I know days to years. I need years to seconds. So I have 3 degrees to get between my years and my seconds. I now have enough conversion factors to figure out where I'm going. So I'm going to start out with 1 year, and I'm going to just put it over 1. Then I'm going to do times. What should my first conversion factor be? I want to get rid of years first. So let's see. I'm going to use this one. 365.242 days per 1 year. That's the conversion I'm going to use. 365.242 days over 1 year. Okay, so now I already know my years are gone and I'm on days, but I still want to get to seconds. This is my goal. Well, can I go from days to seconds yet? No, I can go from days to hours and then hours to seconds. So let's go days to hours. I'm going to use the version of 24 hours per 1 day because that's the one that's going to work. So I need 1 day down here, 24 hours up here. My days are diagonal. They're going to cancel. So I have no units, hours, no units, no units, no units. So right now I'm at hours. I still need to get to seconds. So I've got one last step. I know my hours are going to be on the bottom and my 3600 seconds on the top. Okay, so now I can cancel hours and hours. No units, no units, no units, seconds. No units, no units, no units, no units. Years to seconds, years to seconds. So I now know my problem is set up. So no matter what, I can get the correct answer as long as I multiply correctly. And rather than bore you with a multiplication lesson, we're in science, not in math. So I'm going to do 1 times 365.242 times 24 times 3600, and that is a large number. I'm going to round it to 6 significant figures. So 1, 2, 3, 4, 5, 6. I'm going to cut it off at that 9. 3, 1, 5, 5, 6, 9 times 10, and I'm also going to put it in scientific notation. So my decimal is here. I've got to figure out where it lands on that 3. 1, 2, 3, 4, 5, 6, 7. It's times 10 to the 7. And my units are seconds. And then on the bottom I have 1, 1, 1, 1. Any number divided by 1 is still itself. So that is my answer for how many seconds are in 1 year. Go ahead and write your own summary about unit conversion and dimensional analysis. Feel free to mention that we used some scientific notation to get our final answer here. And hopefully this makes some sense. We are going to be working on some problems together, going through the step-by-step of setting up unit dimensional analysis. And then you're going to be working on your own on some worksheets to hopefully drive this home. It feels a lot more complex than it is, but once you get the hang of it, you can solve almost any problem in physics and chemistry. So hopefully this is good, and we'll see you in Zoom.